Alright, so welcome to our talk on intermediate unit tests. There's a precursor to this one. I'll put a link to it in the notes on YouTube. Basic unit tests. In this one, we're going to cover a lot more depth on some of the functionality that's included in the test suites and how that's applied. Later on, following this one, and as we get those done, we'll probably include those links across these various videos as well. We'll be doing one on React and one on Angular. Might look at Vue or something like that if I get enough interest in that. So let's jump into this. So about me, I come at this number one. I've had a lot of coffee chats with 100 devs folks, something like 270 or 80 or something like that. I lost a little track there, but unit tests are one of the things we talked about. In an hour chat, it's impossible to cover everything you can talk about when it comes to unit tests. In fact, our first video on basic is, 20 minutes long or something like that. And I mean, it's really basic, getting the rough idea of what a unit test is and why we use them. This one I expect is going to be significantly longer, probably on the order of an hour and a half to 2 hours. And maybe another hour on the Angular and React side as we go down the road. There's a lot to cover here, so we're going to jump into it. But first, I want to introduce you to Lewis.
Hey, what's going on, guys? My name is Lewis. You guys can call me Lou. Like on Twitter. A little known fact about me: I love tech. I've always loved tech ever since I got my first PC and started troubleshooting it and everything like that. I've loved that ever since. After that, I really wanted to approach tech, but I didn't know exactly how to approach it, in the professional sense. And then, little fast forward, joined an organization called 100 Devs. Started networking, met Bob, and the rest is history.
Okay. And Lewis isn't here for comic relief. He's to keep me on track because there's a lot to cover here, and it's complicated. All right, and I want to make sure that that I don't gloss over something that I see as simple, because I've been writing code for 40 years, because I've been writing front end code for 12 years, because I've been writing solid unit tests for 6 years. There are a lot of things that I think are simple. I want to make sure that we cover it well here, and that's why we're going to take some time as we navigate through this whole process. Okay, so as we move into the slides here, clearly, first thing you want to talk about is goals of unit testing. I mean, which is pretty straightforward here. There's not much I need to add to this. We want to have confidence in the code we release, that it doesn't have defects. Now, you're not ever going to write code that has no defects. Wow, that's a lot of negatives in there. You're not going to write code that's defect free, ever. Okay? However, you can minimize it with unit tests. Okay? Actually the tech lead on the project that I'm on currently wrote his first front end code the other day. We were paired and I was walking him through it. He did really well with the Angular code. I mean, the concept was pretty simple that we needed to do. But then we got to the unit test, and he had never really done much of anything like that. And one of the things that we caught, and I let him do it with the main code, was the code had a flaw in it. And we caught it when we wrote the unit test. He saw immediately that, hey, I need to cover this scenario. We don't release without defects ever, but you minimize the number that reach production. On the order of about 90% of them are caught at the unit testing phase if you do your tests right. You have proof that your code works. I mean, that's a big deal. Bigger deal than you think it is. Okay? We have to be practical and prudent about our unit tests. Okay? We have to take a look at what function we're covering and how many branches are through and what happens if we pass some odd data type in. I ran into this one just today where the error that I was trying to fix, that I had already pushed code in for, was looking for an empty array. I wrote a one-line piece of code that bailed out early. Well, what I didn't realize was there was another scenario where it could potentially get null. You have to be practical and a little prudent about that. Now, prudent, I might disagree with just a little bit, because prudent would imply to me that I write my tests in a way that I kind of optimize. I don't write too many. Unit tests, I could care less how many. I've seen suites with 6,000 plus unit tests. Yeah, it takes 15 minutes to run all the unit tests. But that's 6,000 unit tests. That's 6,000 checks against your code. Assuming they're good tests, okay? We decrease the number of bugs. That was what I was saying up on confidence, okay? We get to them earlier, before they get to QA, before they get to production. And because of this, our deployments are faster and easier. Now, what do I mean on faster and easier? Well, I've been in environments where testing was my boss poking at my code and liking something or not liking something. If he didn't like it, we went back and we fixed that. And if he did like it, we pushed it into production with lots of broken things in our code. That was relatively fast and relatively easy, a little painful at times because it's directly my boss running my code and testing my code. And
right.
I didn't have any unit tests against that code at that point in time. Now, faster is relative because in that case, 2 minutes I could have a response on whether it's ready to go or not. Without unit tests, lots of bugs in the code. Now I'm much more reliable, much more dependable. It takes me twice as long to write the tests, but this is time down the road that's not coming back at you. And yes, it takes 10 minutes every time I push my code up onto a pull request to see that my test passed. But it's absolutely worth that 10 minutes. Because at one time I forgot to run my tests or something like that, or I forgot to adjust the tests because it was a really quick, sweet short change and that kind of thing. Faster and easier because those things get caught much earlier. I actually had an individual modified HTML and it broke our unit tests on what JavaScript was expecting. It's kind of an interesting one. I'll have to go back and see if I can replicate that somewhere down the road. Okay. So the goals: confidence, proof, practical, prudent, decreased defects, faster and easier deployments. I'm hoping there aren't too many major questions there.
No, for the time being, no.
Okay. So what is unit testing? Okay, I might have done better starting here, but you know what? We've got this far, so this is what we're going to do. Okay.
Yeah.
Unit testing. These are the atomic level of testing. Okay, these are the smallest type of tests you can write. It should be you're testing one scenario against a function. You want to minimize the number of paths through your function. If you have more than 9 paths through, there's all kinds of software that can calculate the complexity. More than 9 paths is so complex, you can't write an effective number of tests against it. So you shorten your functions, right? So 1 or 2 paths through is your general preferred. Okay. And in fact, I'm looking at one now where they're using a switch statement, and we're talking about potentially using enums instead of switches. The switch is against a number. If we've got that enum, can we somehow set this up so that we're using an array of functions? And shorten that to 1 path instead of a case. That atomic level, they're really small, they're really fast. Single responsibility, you want to do one thing well, right? They're repeatable, reliable, and deterministic. And this covers a couple of things here, but at its core, when I think repeatable, reliable, and deterministic, what I'm thinking is I can run those tests in any order, and they still work. One of the ones that poorly written tests will run into is you're not rebuilding whatever that structure is, whatever case, whatever class or whatever that you're testing. You're not rebuilding it at the beginning of the test.
All right. So
you're dependent on the previous test's changes in your new tests. So if you run them out of order, then they don't work. Okay, so these are things we take into account. You demonstrate concrete progress in the growth of your application. Okay, your unit test should fail on bugs or changed requirements. So I change my code and it induces a bug. I change my code because I have a change requirement and I don't change my unit test. Guess what? They should fail. I mean, that's expectation, right? It should be
Right.
really easy to understand why it fails. Now, in the code we look at, let's take a look at how I described a couple things, because they're probably really bad descriptions because this is demo code, right? Talk about how we can prove
Right.
that, okay? Don't let me forget that one. The biggest
Okay.
thing is we reduce the cost of bugs, and this is one that I mentioned before. And there are all kinds of studies, and you can look these things up. If I find a good one, I'll link it in, but I may or may not. But the studies basically have shown repeatedly that finding a bug at the developer level when you're working on unit tests is about 100 times cheaper than finding a bug in production.
Hmm.
Because number one,
Why is that?
well, think about this. You're finding the bug in production, so somebody found that bug, right?
Okay.
If it's an internal user, you're causing them problems time-wise on their pay scale, right? If it's an external user, it's potentially sales that you're losing. Okay, so lost revenue,
Okay.
lost time, which is money, internally,
Yeah.
either way. So once that bug's found, then it's got to be reported. It goes into a reporting system. That reporting system, somebody's monitoring and watching that, and they pay somebody to do this. We have one person on our team. In fact, mine's coming up in a couple weeks where I get a whole week. All I got to do is monitor for bugs. My time to monitor for bugs reported, and it could be anywhere in our application front end or back end. Okay.
Yeah.
In fact, we have cloud, we have databases, we have that kind of stuff too. So it could be in any of those areas. Then I got to find the right person. And it might take me half an hour even to understand what was reported. Okay, because here's one of the big ones that you'll find in the industry is users of your software, number one, will find an insane number of ways to break your application that you never expected.
Yeah.
Number two, they're horrible at describing what they did. I've had descriptions of your application's broken. How do you repeat that? Okay? Getting clear descriptions of I did A and then B and then C and then D and this is what I saw. Now you got to take that and you got to run through the application, see if you can repeat it. Because the worst bugs are the ones that you can't repeat it. And I've actually seen bugs where it took 2,000, 3,000, 4,000 repetitions of that list, of that scenario, to actually see the bug hit. Did you have enough breakpoints in your code and that kind of stuff to catch what the problem might be?
Yeah.
Because if you don't, guess what you got to do again? All that's time. That could take, it could be a couple hours, but it could be a couple weeks to do that. Okay?
Oh my God.
Just to figure out why you have the bug. Now, from there, that bug, that diagnostic, any of that you get gets put into a card. Now you've got your Scrum Master, your business analyst, your three amigos, so your front end, back end, and QA, in a meeting, and they'll talk about this card, and this card gets worked on. This card may get as much as 10 hours of those people's time. Figure out where the problem is, figure out potential solution on the problem, making sure you've got all the requirements to test to see that it's done once it gets to the business side of it. All this stuff has to get filled in. Then it has to go in front of the team. You got a team of, let's say, 8 people
Yeah.
that will look at that card for probably about an hour total.
Okay.
Okay, before it gets pointed properly, and then it gets pointed. Then it goes into a sprint. Then somebody's got to do the work, and that could be an hour. It could be 2 weeks time.
Right. Right.
Now, you've solved the bug, but you're not done yet, because guess what? Now it's got to go into dev, and it's got to be dev tested. It might be you the dev test, might be somebody else, but that's still time.
Right. Right.
Now it goes to stage. Now it's got to be stage tested manually. Manual tester, their time. It's got to run through automation tests. You've got an automation tester who has to write tests against that bug to make sure that bug doesn't come back at you, right?
Yeah.
Then it's got to be looked at by the business. And if it passes all of that, it goes to production. Guess what happens if it doesn't pass all that? It goes all the way back to the beginning and comes back through that loop again. Okay? Time. It's 100 to 1
Time. Yeah.
on average. Okay? So if you're 100 to 1 on average, then some of them may be down as low as like 10 to 1. But some may be as high as 1,000 to 1 in time.
Dang.
Okay? So catching them early is important, and unit tests are a critical piece to that, because my estimates, and I mean I've run numbers over the years, and somewhere along the way I've got the numbers I ran, probably on one of my DevTO articles, where I show with my code 9 times out of 10 I catch it at the unit test level. If you're running good tests, that's important. Okay.
Yeah.
All right. So what is unit testing? We kind of beat that horse, so I'm going to move on here. Okay.
Let's
go into an overview of what we're going to cover here. And I got my nice little testing Dorito, and I stole this. I'll be honest, I'm blanking on who it was I stole this from, but I made a cleaner version of it. He's got a pencil-driven version of it. It's out there. If you look up testing Dorito, you'll find it. Okay. I'm not claiming this is mine. I just made a prettier Dorito. Okay. We're going to go over what Stubs, Spies, and Mocks are. I left Dummies in there too because Dummies are really, really simple conceptually, and it's not something you're writing any test code for, but you need to know the concepts there. Okay.
Uh-huh.
Stubs, Spies, and Mocks are different ways of essentially doing the same thing, of controlling the behavior of the code, of isolating down to the code you want to test without outside influence. Okay. We're going to talk a little bit about code coverage. I actually want to show some code coverage here. Okay, we're going to talk through the code examples we look at, asynchronous activity, dates, reading a test failure. Okay, we're going to break a unit test somewhere along the way and show you what that looks like. How do we read that? How does it become easy to figure out what failed and why?
Awesome, yeah.
Okay. So, stubs, we go into definition. Stubs provide fake data to the code under test. Okay, and code under test, you hear it described as other things, suite under test, that kind of stuff, but it's all the same thing, what you're testing. The spy records information about what you're testing against, some portion of it. Okay, spies on it, makes sense. And then mock defines an expectation of how something's going to be used. We can actually cause failures here with a mock if we don't do it properly. Okay. But at its core, we're controlling the behavior of our code. Okay, allows us to test things a lot easier. So a lot of times, here's a definition. This comes right out of the Angular testing guide. When abstracting external parts of a program to test code in isolation, we mock or stub some of the code that gets plugged into the tests. Okay?
Okay, yeah.
So what we're saying there is we want to isolate our code. We have external influences. What are external influences? Well, if I'm testing a function, and we're going to see one of these, that makes an API call, that uses the fetch command or Axios or whatever. I don't actually want to make an API call. Right? I don't want my unit test going to make an API call. If I'm connected to a database, I don't want to go get the data out of the database. What I want to do is some way intercept that outgoing request and give it back something I can control. Okay? At the same time, I might want to be spying on that call that goes out to say, hey, did I get the right inputs? Right? Were the right things passed to the function? That's where spying comes into play. Okay?
Got it.
So, definitions, we talked about code under test, subject under test, system under test. They all mean the same thing. You'll hear these referenced a number of different ways. Under test is the important part. Okay? This is the testing pyramid on the right. Unit test, or the bottom part, the absolute most that you're going to see. Okay? We'll talk about integration and up here in a second, but definitions, dependency. What is a dependency? Dependency is something that's injected in. So think of a class. Class as a constructor, right?
Yes.
So if I'm making an API call in Angular, I have to inject a dependency on the HTTP class that Angular has set up. If you're using Axios, you have to inject Axios. You're importing it somewhere along the way to be able to use it, right? It's dependent on Axios. It's dependent on HTTP class in Angular, okay? Mocking. A lot of what we're talking about here. Test doubles, stubs, proxies, mocks, spies. technically, by definition, they're different things. They're doing that same thing, as I said earlier. Okay?
I was gonna ask. Yeah.
You'll hear me interchange the words a lot.
Yeah.
All right. In their purest
So does mock do? I'm sorry to interrupt, but in the mockings, like, does mock replace?
We'll see that. I got more detail on that as we get through.
Okay. Okay. Cool.
Okay.
Cool.
What
Yeah.
what I really want to point out here is, while we are going to go through the technical definitions, in my 6 years of writing unit tests, the technical definitions mean almost nothing. Okay, it's the application of them to control how your code behaviors and or monitor what that code is doing.
Got it.
Okay, the technical definitions are set aside. There, I mean, there no point am I saying, hey, add a spy here. I'm saying, hey, type spy on, and this is what you're going to spy on, and this is what we're going to return, so we know we get the right data. Okay, it's in Angular, that's a way to mock, to replace. Okay. So pyramid on the right, unit tests to the bottom level, as we said. We also have integration tests. Okay, so what I tell people is, in the simplest form of an integration test, people always argue differences, but at its simplest form, an integration test is any time two functions are talking to each other. Okay, if you're allowing both functions to do everything they're supposed to do, most likely that's an integration test. So it is possible in your code you're going to write some integration tests and not realize it. They're not just testing on one function. Okay, and that's okay. It doesn't hurt anything in smaller scenarios. Okay. In the case where I'm using Axios to make that external call, if I actually use Axios to make that external call, that becomes an integration test.
Yeah.
Okay. You're testing larger chunks of your code at one time. Okay. Next level up are, and there are less integration tests than unit because they're more complicated, UI and API tests. Okay, these are more complex integration tests. You're testing a whole page. You're testing a whole component and all of its child components.
Right.
Okay. At the API level, back end, you're testing all the way through to getting data and coming back out. Okay. At the very highest level, you have manual and exploratory tests. Okay. In kind of in between those are where your automated, your UI and API cover a lot of the automated tests as well. Your manual exploratory really are your truer automated would fall in there. Okay, so your manual testers will be testing various scenarios, and the reality is you'll put a new feature in and they might test it for 3 or 4 hours. There may not be an automated test written against that. Okay. Automated tests you have to be very sparing with because they're at the top of the pyramid, but they're the most optimal, and guess what? They're radically the slowest. Okay, I've seen 300 automated tests that do everything from spinning up your application, logging in, going in and doing a couple things, coming back and logging out. I've seen suites of automated of 300 tests that could take 3 or 4 machines 12 hours to run. That's slow. When you're talking 6,000 or 7,000 in 15 minutes of unit tests, automated tests are slow. So you got to be very particular about what you test there. Okay. There's also another offshoot category of automated called smoke tests. So those tend to be like the top 6 to 10 most critical automated tests. Does login work? Right? If you're running a website and you're selling something, does my payment process work?
Yeah. Okay.
These are things that have to work every time. And a smoke test will be run as a part of the CI/CD pipeline. So somewhere in there, that smoke test, if any of those 8 fail or 10 fail or whatever, halt the buses because we broke something critical. Okay.
Yeah.
So your manual is going to test a little more than the automation because automation, by its nature, can't cover everything. Okay. All right. So lots of definition-y stuff. Don't get too wired into definitions. I do want to look at the anatomy of what we call code under test. Okay, so I've got a basic function here, and this is one that you would see a lot. You know, whether I'm in Angular or React, this is pretty standard for getting data. Now, the fetch here in this case is getting the user JSON. It could just as easily be going to mycompany.com/API/get users. Right? Some API call that goes out to a database, it goes out to the cloud, wherever it goes, I don't care. It's a fetch. Okay, fetch is a JavaScript command that we can use to make an API call, right?
Right.
We await that response. We get a result. That result has to be converted into JSON because it comes in as a string.
Yep.
And in this case, I'm running an adjustment. I want to change the dates to some format that's more readable because dates often come in this really ugly format from the database that
I didn't know that. Okay.
users don't like. Yeah, it comes in with things like 2022-10-05, T,
Got it.
the T in the middle, and then all this other stuff. And if you have a Z at the end, that means that you're on UTC time and you've got to convert it to local time and all this. So they're really ugly looking. So we have to change it in some way. Okay, so I do that conversion here and I pass it in. And I return the adjusted. And the adjusted is our entire data set with those adjusted dates added onto it. Okay, I wrapped all this in a try-catch. It's async. And if I have an error, this is the simplest of the try-catches you could do. I want to keep this short so I can fit it on the screen, which is I return an empty array. If there's any kind of an error, just give me an empty array back. Okay? Don't console log it. Don't throw it anywhere. You could console log. I probably wouldn't return an array back normally, but that's, this is what you can do.
Okay.
So how do I look at this code? When I look at this code, it jumps out at me. I have 2 branches through. Right?
Right.
There's 2 routes through. So at its base, at its minimum, I want 2 tests. Okay? But as I look at this, I'm not really worried about the bottom one. Okay, so right down here, the return, not stressed about that one. That's pretty easy to test. Up here, look at this. I have 2 different things going on here. Right? I'm getting my data in the first 2 lines. I'm adjusting my data in the second 2 lines. Okay, so I got to make sure I cover, I can cover those in one test. But we got to be aware that these are actually 2 separate things that occur. Okay. It's not real complicated. Okay. So we're going to do a couple things as we run through this. As we look at this one in our try block, somehow we're going to have to spy on or mock that fetch. Force it to return some data that can process this JSON. Okay, I've got this example in the demo code. We'll see it. Okay, but this is how I look at it. This is how I think about it. Also in that try block, I have that process dates, which, hey, I can literally spy on or mock that process dates so that it returns that array so that I look at what's returned and say, hey, when we ran that, it returned something. I control what it returns, right? I could let it run. I could let it run the process dates and make sure it has a date in there that's convertible. Okay? So just a quick run through looking at a chunk of code and how we think about it. And we're going to look at a lot of chunks of code later on in real code, not copy-pasted code. Okay? So going a little deeper into those definitions, and we'll look at code here in a minute related to this. So stubs. Okay, so here we're returning a known value, a known and controlled value. Okay, so in a sense, a stub and a mock are very similar. Okay, what I'm doing here is I'm saying, hey, instead of using employee, I want to use this stub of employee. Okay, we replace or redefine, and in both cases of stubs and mocks, you want to be careful of not creating a whole new object. It can be done that way, but there's a lot more management on that side. There are ways to do it with stubs and mocks that uses the original classes. So in this case, here, the employee system, we want to somehow duplicate that employee system in a way that we can control what comes back. Okay? So that's a stub. So, some code here to look at. So what we've got here is the very top half. Oops, sorry, I'm moving my mouse on the recording screen, not on this one. So what have we got here? So this is a code under test up top. Okay, we've got a count, we've got a counter increments count. We pass into this app function. Now, this counter is not, these are not the same counter. This is a variable passed in on an arrow function. We named it counter, the same as counter up here. Okay?
Oh,
It executes
okay,
counter
yeah.
increment. That's all app does. Okay, the nice part in doing it this way is I can stub out the mock counter and create a whole new one. Okay, so what I'm doing here is I'm looking at app and counter and saying, okay, how do I test this? Well, I'm mocking counter. I'm creating a mock of this. I'm creating an increment on it that has a jest function. This is the stub.
Ah, okay.
Okay, the biggest thing you should catch here is that if we app passing at mock counter, nothing actually gets incremented. The count up here does not get incremented because we stubbed the functionality.
Okay.
Okay, we bypass this counter altogether at the top. So what we can do is we can now expect that increment was called one time. Two have been called one time, right? Two have been called times. It's the weirdest naming, but it's there. We can execute counter get count, which should return that value. It should still be 0. It never actually fired because of the stub. This is not the way I would write a test. I don't want to test that it didn't work that way, right? I put the mock in so that I could test that it actually called increment.
Oh, okay.
Or, sorry,
okay.
that stub in. Okay? This is just to show you, when I run this code, that because I used the stub,
Mm-hmm.
the original functionality got bypassed.
Okay.
Because I use the stub, I can directly check that increment was called. Okay, there's a positive and a negative in using the stub. Okay, so there we go. So we're gonna take a look at the repository. We're gonna take a look at some code.
Awesome.
Okay, this is the exciting part. This is when it gets fun, and this is when weird things happen that make my life really interesting. Okay, font size good.
Okay.
I noticed in my last recording I had the font size really small, so people are probably squinting a lot at it. I'm hoping we don't have to
it's
squint as
perfect.
badly on this one, right? Put it up on a
Wicked,
big
wicked.
50-inch TV, you know, much bigger than and easier to read.
I should
Right.
probably do that, right?
So, the repository here, okay? The presentation is there, and I'll make sure it's updated. The testing Dorito image that's in the presentation's on there. It's a really cool image. Whoever originally wrote that, I hope you find this and get the clean copy of the testing Dorito, because
Yeah.
it was a really cool concept.
Mm-hmm.
Okay, the README. This is an important piece. Okay, link to the slide deck. Link to the file in the slide deck. The unit and integration testing article that I wrote a long time ago is out there, and it's a really good article. Okay, I'm hoping you read it.
Yeah.
It's okay
Yeah, I
if you
did, I
didn't.
did.
It's a good article.
No, I did. I
It's a good article. It's a long article. Okay, I understand that.
I didn't read it completely.
Okay.
I was on vacation.
Now, last time Lewis and I were together, was that 2 weeks ago on this?
Yeah.
A week ago?
Yes.
Yeah, it would have been before your vacation, so 2 weeks ago.
Yes.
We did run through these setup commands and found a flaw, and it's fixed, so this is right.
Mm-hmm.
You're going to install NVM on your
That's
machine.
why I asked you earlier if you made any updates.
No.
But that's what I meant.
Yeah, okay. Okay,
We
good.
fixed yeah.
So you're going to install NVM, because NVM use will
Yeah.
make sure you have the right node version on your machine. This repository requires a specific one. I did find that fetch is not in 16. It's in 18, which is in this. So we make sure you're in the right place for that. You'll want to run npm install, because you'll get the node modules all related to this project. Okay. Running the unit tests, you can use npm test. You'll see me many times running Jest instead of npm test. It's the same thing. Okay, and I'll show you in the
works
package JSON how that works. I have Jest installed globally on my machine, so a lot easier for me to run that type 4 characters instead of 8 up here. Okay, I'm lazy. When you want test coverage, npm run test coverage or Jest -- coverage. Coveration. Wow. Okay, so there is
There
a
we go.
fix that has to go up. It will go up before I release this video. Okay. Next piece I want to look at, and I hit Control Save, not Max Save. There we go. There we go. So next thing we want to look at is our package JSON, and really all we need to look at are the scripts, because we have tests and test coverage. npm run
There you go.
npm those, and they work. Okay. Notice it's Jest and Jest coverage. Same thing as you saw in the README. Okay. Either one works. And the reason it works is we've installed Jest and all of its associated pieces into the node modules locally. Okay. Let's see. And then in source, I've broken it down into mock spies and stubs. Now notice coverage and node modules are grayed out. You're not going to get coverage as a part of it. You have to run the Jest coverage. I've run it, which is why that's up there, and we'll talk about that later in here. Okay, so we're in here to talk about stubs. At this point, we're going to go back to the presentation and back to the code again a couple of times. We're going to take a look at what's in stubs. Okay, and stubs are really simple. They're used a lot. Okay, in various scenarios. Now, I did pick Jest for a particular reason, and it didn't have to do with stubs. It didn't have to do with spies.
Okay.
What it had to do with is mocks. Okay, I just want to explain this before we jump too far in, because folks will ask me why don't you use Jasmine? Jasmine's what I use primarily with Angular, which is where I spent the last couple of years. Okay, I've got equally as much time with Jest. The biggest factor for this presentation is that Jest has true mocks. Angular and the Jasmine library do almost the exact same things with complex spies. Notice in either case that I talk about stubs. Okay, stubs are not a complex topic, but they're useful. Okay, so let's get rid of the package here. Let's get rid of this mock file. Oh, close that back down and come back into our stub set of tests here. And these are the really simple stubs where we got a test object, and the test object does a console log. Okay, inside the test object you have a function log something. Not a complex set of functionality, right? And it console logs this does something. So our test suite, and I wrap this into scribe and before all, and you'll notice one of the things I want to point out is I used it. There's a reason I use it, and I'm kind of, this is one of those my little pain points. You can use test. Okay, you still have the describe, you still have the before all, after all, that kind of stuff. In Jasmine, they use it. There's no tests. Okay, so by using it, I've got the same functionality on both sides, the same description. Okay, and there are a couple other, you'll see a couple other minor variations here that I show. In fact, this function has one of those. So it expects the sub to be called. Okay, notice we have to be called. My preference would be to have been called. To have been called is the chained function that's used in Jasmine as well, so the naming's the same. So I'd rather use the it, and I'd rather use the to have been called, because the naming in the two suites, when I'm switching back and forth between Angular and React, I don't have to rewire my brain for testing.
Got it. Yeah.
Okay. So yes, I could just as easily have said test.
And it'll do the same thing.
Now, here's a point that I like to point out. Test expects stub to be called doesn't roll off the tongue as well as it expects stub to be called.
Okay.
Right? Okay. You want to make it as natural to read as you can, right? So what did we do? Let's take a look at our before all. So what happens with before all? This is a one-time thing. Okay? You have before all, after all, before each, and after each, and they do exactly what you would expect. Before all runs before all tests. Right? After all runs after all tests are run. So if you have cleanup, you could do it in there. Before each runs before each individual test runs.
Mm.
After each runs after each individual test runs. Again, you could theoretically clean up there. I don't generally use before all. I'd rather use before each. In this case, it didn't hurt because all I'm doing is setting up a spy. Okay, a mock implementation of console log. What we've done here is, with this before all, is we basically said, hey, when somebody tries to console log, I don't want it to do anything. If I take that out, when I run my tests, I get a whole bunch of console logs fire out when my tests run. By putting that in, I don't get that garbage in the test run. Okay?
Right.
So what are we doing here? Well, we've got the code up there. We created a stub. You saw the stub, right? Jest function.
Yep.
Looks just like the stub we saw in our bigger one. We run this stub variable, execute it. It's a function, right? We can expect it to have been called, to be called, and to have been called. I mean, logically, without even running it, that makes some sense, right?
Mm-hmm.
The stub was called. We didn't actually stub anything in relation to our function up above. We're going to get to that. Okay?
Okay, cool.
At the same time that you can test that a stub was called, you could do a not to be called, or a not to have been called. I can test that it did not occur, which is a powerful thing if you think about it, right? Failure. You want to test that a lot of things didn't occur on failure, right?
Yeah.
Okay. Now, here's the same kind of implementations, only in this case, I'm using something spy, which is spying on the test object. Remember that up above? Oop.
Mm-hmm.
There we go.
Oh.
There we go. Test object. Log something.
There it is, yeah.
Okay. Scroll back down. We're spying on the test object, comma, log something. And this is the pattern. Okay, so if test object had more layers, you could do test object dot functionality dot whatever dot the very last one, the last key that you're using on that object, you put inside a string. Okay?
Yeah.
It's just how you do it. Okay. I'm not even sure why. It just seems kind of weird. I type it wrong all the time and then have to go back and fix it. So then I execute test object log something, and it's going to try and do that console log, which we've already stubbed out, so nothing's going to happen. But since we've spied on it, we can now check that something spy, which was the name of that stub, we can check that it was called. Okay, that's a step closer to actually testing our code, right?
Right.
It is a test of our code, but let's take this a little bit further. Okay, so in this case, I'm gonna hit the enter key here so you can see this.
Okay, there we go.
We're setting up a mock implementation. Now, mock implementation typically takes a function. In this case, we didn't pass anything in, so it's going to assume, and those of you that like to be technically correct, I'm not technically correct here. We're just going to assume it's a function that returns undefined. What we've got in here is undefined, right? There's nothing inside those parents. Okay? So we can expect it to have been called. Okay? It's the same, essentially the same test.
Yeah.
Same expects, right? Now, if we do a mock return value, again, same thing. The return value here is undefined. We could put something in there. We could check to see if that value was correct that was returned. We haven't gotten that far yet. Okay. So, let me make sure I get all my changes out. There we go. And let's run this. Why is Quaco? That's weird. One thing I didn't check, right?
Yeah.
This should be my terminal. Why am I not in my terminal? There's my terminal. Hey, much better. Let's go to a terminal. Okay. ZSH likes to update all the time.
Yeah.
That's okay. I don't mind. Doesn't take long.
There it is.
Get your swag. Okay, where we at? It's not done yet. There it goes. Oh, there we go. Hey. It's running faster than I am.
There we go.
Alright, so I'm in main. All my code's in source. We don't even have to CD into it, right? We could do just source / stubs / stub hyphen 001 test jazz, right? We hit the enter key and my machine is running really slow. I did hit the enter key.
Yeah.
It's doing something. Oh, we're running. Yay.
There it is.
It'll go faster. I'm not quite sure why.
No, you're right. Yeah.
That's slow. Oh, there we go. It ran, and you can see that each individual test
Look at that.
passed. Okay? That's the code we just walked through. Okay? So, having seen that, don't need the PNG. Let's get past that one. Let's take a look at the second one. Okay, this one,
All right.
same code, right? And here, we're using a mock implementation that uses a stub. We've seen this one, right?
Yes.
Okay, so we're testing it to have been called one time. Counter does an increment. And we're going to run this to see that this worked. Okay. And here, instead of using this stub, I'm going to use a spy. We're going to step into spies just a little bit. Just like I want to see you to see if there's other ways to do the exact same thing. So increment spy spies on the counter increment. It's spying on counter increment. So we're actually passing counter in instead of the mock counter. Okay? We're passing the real counter in, but we spied on part of it. What does that mean? It means we spied on it. It means it hasn't changed its behavior at all.
We're just looking at it, yeah.
We're just looking at it.
Right.
Okay? So we can verify that increment spy was called one time, just like we did up here, right?
Mm-hmm.
But we can also check that get count, and it should have incremented by 1.
And that's when, okay.
Okay? It's the real functionality. We spied on it. Not always the best way to do it.
How come?
Okay. Well, what if the function you're spying on is that fetch command? Do I actually want the fetch command to fire off and go to the API address and get the data and fire that back?
That's too much. No.
Okay. Well, it's not even that it's just too much. Think about this. If, let's say, what database do we want to look at? Let's say a database of movies. Okay. And it returns you the top 100 best movies. How do I write a unit test to test that I got the right 100 top best movies? It's going to change day by day, week by week, month by month, year by year. My tests are going to need to be changed every 5 minutes. What I want to do is I want to mock. I want to stub, potentially spy on and change its returned value. Okay? Using the true implementation is good if the scenario is right. This is where we have to be somewhat smart about the tests we write. Okay? In my mind, looking at these two functions, all I'm testing with this first one is that increment fires. Knowing that my functionality is not real complicated for increment, this might be a better test to test that it actually incremented the value. Okay? So let's run this, and hopefully my runner will go a little faster for us here. Could be wrong on that.
I think I heard you.
Yeah, I'm not sure why we're running so slow, but we are running. Okay. 5 seconds. Wow. That's really slow, I'll be honest. Even for my machine, that is insanely slow.
Really?
Okay, so they both pass. Okay. We have verified that we're getting 1 back here. We have verified that it did not actually fire the true increment.
Yeah.
The intended one. Okay. So let's look at the third set of stubs here. Okay, here we've gone a little further. I've got a multiple add, I've got a counter. An add adds a state and a value. So bringing the value in, I'm adding it to state. Okay. Get count that returns the state. It might have been better to name that return state. Yeah, that's what I did. Okay. So we got a single add, which is very similar to what we did before, but it's adding 10. Multiple add inside that function is adding 15 and 20. So at the end, we should have 35 if we ran that, right?
Correct.
So we've seen the mock. Mock is stubbing out the add. Okay. The big drawback in doing this kind of thing also is we can't test the get count because we haven't stubbed that portion of it out in the mock. Okay. Mocks can be dangerous because they don't have to be an exact match to the original functionality you're trying to test, original class or object. Okay, but let's go down and look at some of these others. So we expect single add. I only have one single add function because single add really isn't complicated, right? It's taking the counter and adding 10 to it. Counter.add,
Okay.
right? So if we look at the single add, we're spying on counter.add. We execute single add passing it counter, and we should see that add spy was called with the number 10. Right? Counter.add
Yeah.
10. Okay. In the multiple, here it is
Right.
with the mock. And the mocked the add. We do a mock counter add, checking to see that it had been called with 15. Okay, here's the interesting part. The multiple add actually calls counter.add 15, counter.add 20. Okay, our mock has add. So yes, it did call with the right values. It didn't increment anything. Okay, here's the same thing doing with a spy. So we spy on counter add. We run multiple add. We can see that it was called. We see it was called. The assumption here would be we could run another test to verify that our state is now 35. We didn't write it, but we can assume that, right? So let's run this third one, give it our 5 seconds, and see what happens, right? So,
Let's do it.
you know, do I have to actually explicitly say that? I don't know. That's an individual choice. Depends on the complexity. This is super simple code that we're looking at here for Stubs. Okay, so
Okay.
do I need to write
Sounds like a little longer.
little? Not real stressed about that. That's just
Okay.
my machine's being a little weird, probably because we're recording and doing all this at the same time. Okay. So Stubs. Okay. We're going to clear over here, and then we're going to go back to our slide deck. And let's jump forward into the really cool area, which are spies. And if you haven't seen Spy versus Spy, awesome stuff.
That's a classic.
Way back in the day. Okay. I love that image. I found this somewhere, and it was like really cool. I'm like, oh, I love that. It's perfect for what we're doing here. So
They need to bring that back.
spies are essentially stubs that gather execution information. You saw what we were doing there with the few spies that we did. We could see what happened to the function as well as allow that functionality to run, right? Did it get called? How many times? When? With what parameters? You know, unlike stubs, the spy wraps the target function, doesn't replace it. So the target code can still execute. Okay. So spies code. Okay, so here we've got a method class with an instance method, and it doesn't do much of anything other than return output from the instance method. Okay, I'm trying to keep simple examples in some cases. We get into some depth
Fair enough.
when we look at the example code. So we're describing our spying 101 or 001, and here we have a class. Okay, we're going to call this class in our code. I'm going to call it a service, and this is the pattern I use in Angular. It works just as well in Jest. And before each, since I've done that as a let, I can change it. Right? It's not a const. I set up a new method class. So before each test runs, I reinstantiate that method. I create a whole new instance of that class. The advantage of that should be pretty clear. Everything's reset back to 0. Right?
Right.
An individual test doesn't depend on any other test because the whole service has been replaced. Okay, and I ran the Jest clear all mocks just to make sure any mocks we had in there get wiped out. Okay, so in this case, we could do a Jest spy on service instance method. So service is the instantiated version .instance method, right? Service, instance method. We're creating a mock implementation that returns spy triggered. So we shouldn't see output come back. Now, think about that. In our original, the spy did not change the original implementation. But remember what I said with Angular. We don't use mocks because we can do almost the same thing with spies.
With spies.
So in this case, I'm spying on it, I'm changing its implementation. So now I can check that I called it with the right variables, and I can control its return value. So as we look at our execution, we're getting the result coming back from service instance method. We can check that it was called, and we can check that the result equals spy triggered, not output from instance method. Kind of a cool way to use a spy, right?
Yeah.
So the pieces we looked at, instance method, the service new method class, that's a critical piece that we newted up. Okay, that Jest, where we did the mock implementation, we essentially did the same thing that a mock does. We're controlling the output so that we can test for a specific output, especially if that output's complex in some way. Did you have a question there?
No, no.
Okay.
We're good.
All right. So let's go look at code, right?
Yes.
Always more fun to look at code. All right. So now we're looking at spies. And it just happened to be alphabetical that way. I'm not going bottom up for any particular reason. That's alphabetical. Okay. Let's look at the simple layer. Okay. Nope, we don't want to look at the PNG. That's the one that was on the deck.
Oh.
Okay.
Got it.
Oh, plant light. So, same class method we saw. Here's the spy 101 before each. We've seen this, right? Here's the spy on with the mock implementation. Here's the spy on without the mock implementation where you're checking the output. And we're checking the spy triggered. Both scenarios, right? So, let's do a Jest source spies spy hyphen 1. Oh. I have to do the JS because I have the PNG in there.
Image.
Yeah, the tab can't. Oh, I got too many periods. Oh, hang on. Too many periods. There we go. Now we wait our 5 seconds. I'm sorry about the 5-second delay. That was an unexpected side effect of running a lot of software on a machine that's about 2 years old. All right, so here we go. It worked. Both worked. Both gave us the outputs we expected. Anything complicated there? I'm trying to start with the simple and work my way up, okay? And we don't want to spend a whole lot of time on these because we want to look at some of these others. So I want to look at this random one next. And random is built up of 3 parts, so it's going to take us a few more seconds to go through. But I'm going to start with the FNS, which is functions. And we have a get number function. Okay, and the only thing exported from this one, it could be a series of functions. In this case, it's just one. And all it does is give us a random number between 1 and 10. Simple. Okay. The reality is we don't test that in this at this point. But I want to look at the app that brings in that functions.
Oh, it brings in that function, okay.
And then in add, we have an add function that takes an A variable and an F. The A is added to the F executed. So we're assuming that F is a function. We pass it. We're assuming that F might be that random function. Right? So a number plus a random number between 1 and 10. And we export add. Okay. How do we test this? Okay. In Spies, we bring in FNS. Okay. And I created an add function here. That's pretty much the same as what we had at the app level. I could have imported the app one, but I wanted it to be visual as you see it right here. Okay. The assumption that FNS is what we're actually adding to A. Okay. And we describe random spies. Okay. It expects add to use spy. Now this brings something up that I want to talk about. And this comes to that whole, how easy is it to find it when something breaks? Okay. If I had, let's say, 200 or 300 functions in your FNS and say 50 or 60 in my app, how easy is it going to be to find add in that list of what might be 300-400 tests? Okay. What I do is I use that same pattern. It expects whatever the function name is to do whatever it is to do.
Right.
Simple sentence. But I always put the name of the function in double quotes. Makes it easier to search. Okay? If I don't have it in double quotes, then somewhere down here I've also got add, and if I search for that, I'm finding it all through the code. If I've got double quotes around it, in your definition of your function, that's an isolated case. It's much easier to find. Okay? So, we're spying on functions get number. Okay? And we're creating a mock implementation. Let me hit the enter key so you can see it. And to return 3.
Okay.
So that's a number between 1 and 10, but it's not random anymore. We're making sure we control that return value. It makes our testing much easier, right? So, given that, we get the result from add 2. We expect the result to equal 5.
5. Okay.
We expect the get spy number to have been called. Now, this mock restore resets it, clears it up.
Oh, okay.
Okay, I could do it in the test. I can do it in an after each or after all, wherever I need it. Okay, if you're running into problems of a spy doing something unusual, those mock restores really help. Okay, so let's test this, see if it's working. Oh, we need to change our path, don't we? Completely. So we're in source spies random. Yeah, so this should run pretty smoothly. And when we get to the API service, that's where we want to break something so we can see how to look that up. Okay.
All right.
So we passed.
There we go.
Nothing surprising that it passed so far. Yeah. Let's look at the API service. This is where things get cool. Okay. An API service. These are going to be longer. You're going to have a lot of things going on, and my API service and your API service shouldn't be radically different. You do essentially the same things. Okay. Now, I do some timing things with days, so I have this definition of milliseconds in a day. I have the get users. That look familiar?
Yes.
I tried to keep it simple. Okay. I also have a filter users that takes in users in a search term with a regex that lets us filter down on a username. Okay. We have this process dates that we used up here that takes the data, loops through each one, and processes the day. And then in the process of the day, it checks to see if it has a start date. If it doesn't have one, it sets days equal to null and returns. In this case, we grab the start date, so it's a new date. We make it a date function, right? A wrap it in date function. We check the difference between now. Now realize what I did here. This is one trick I did to help my testing. I passed in the date rather than declaring the due date in here to determine now.
Got it.
Think about this from a testing perspective. I want to control things. I'm a control freak, right? Okay. By passing now in my test, I can set up now to be whatever I want it to be. It's not dependent on the actual current time that the test runs, because I'm passing it in. Okay. So we just do some math on the difference, and we attach that to items.day. Item is a reference passed in, so it's updating the array directly. Okay. So that's my API service. Nothing complicated in there. A lot, but complicated. We bring in the service. We're mocking some users up, just usernames at this point. We did our same service, newed up the service before each, right? Here's get users. So that was that first function we were looking at. And let's see, let's see how small I can get you. Whoa, I don't want you that small. Where'd it go? I don't need it off the screen. Okay, well that's as small as I can go. Let's see. The problem is going to be I'm running out of floor space. Let's do this. There we go. A little better. So we're looking at get users. That's the one we're familiar with. Okay. And if you look get users, we're doing get users to get users and get users to reject. So knowing that, let's just kind of get this out of the way a little bit. So get users. I went spy route to do this. Okay, so I'm spying on global fetch. Okay, and I'm mocking the return value. Think about what we're doing over there. We have an await because we got a promise returned by fetch.
Yeah.
That promise has a promise. JSON is actually a promise that resolves. That's why we have to await it.
Got it.
Okay, so to mock that correctly, it gets a little weird, but we have promise resolve, an object that has JSON on it. That's a function that resolves those mock users we had up above. So we handled that one function right there. The first 2 lines of code.
Yeah.
Okay. Now I create this mock return value. It has a bunch of start dates. Okay, because here's one of the things I want to point out. I've taken care of these 2 lines of code, and I can verify that they ran correctly, right? I can trick the system into returning a process dates that I can then validate. That's what's coming out. Okay. So I create this mock, I spy on service process dates, and I return that mock. We expect that result will equal expected. Okay. It's really simple, and I can dig in a little further if I needed to, but that tests those 4 lines of code.
Yeah.
Okay. The rejection, the catch part. Guess what I have to do? That promise then becomes a reject instead of a resolve. So when that first line there, line 8, rejects, it kicks down to the catch, passing the error through. Okay, and then I could test the result as an empty array. Yeah, I could have tested what error was passed in and that kind of stuff if I had a console log or something like that in there. And you can control that too. Okay. So we had that filter users. It uses the regex. And it returns the filtered list. So I gave it the mock users. I gave it a search term of Bob. I'm checking single return lowercase. Okay. With our mock users, there's only one Bob in there, right? I pass it in, I get back what I expect, which is the username Bob is the only one to filter down to. But one of the things you should point out on that regex is that I used the I on it when I built it. Case insensitive. The case insensitive allows me to handle things like I don't have to make both of them upper or lowercase. It's regex, right? Let it handle it. Regex is already slow enough. Okay? Let it handle it. So I can check it with lowercase, with uppercase, and see that I get the same results. Okay? I send it an empty search term. I built it in such a way that if the search term is empty, it returns all values. Okay, so you just check the mock users equals mock users when it's empty. Okay? And then checking that I pass a value in that's not in my list. My list was Bob, Jen, Patrick, and Ann. Okay. Here I tested that when I pass in Tim, I get an empty array back because there is no Tim. Right? And then the process dates is really easy because that's just the data for each. And I set up the process day to return an object. Right? Item processed. So I use the spy to change its functionality. So that would be this process day right here. Changing its functionality. I don't care what I pass it. I'm going to change the functionality so I can control what's returned to data. Okay? I give it a date, a now. Remember I could pass in that now?
Right.
Okay? And I pass it data now. And it should be called with, process day should be called with data now. I don't care that this is returned. I used that just as a control. I can check that.
Okay.
I used it as a control. And now is one of those ones we talked about on the slide deck. Remember dummy?
Yeah.
Yeah. This is a dummy value.
Oh, okay.
It's only there because the original function requires it. We're not actually using it to do anything in that function. It's passed through. Okay? So process day is where we spend a little more time because we have to check empty and we have to check a couple things there. So handle no date. Remember I had that no date that changed it to null, right? So I pass in an item that has no date and a date time stamp, right? Pass those in. At the end of that, item should have a property days. True. But item days should be null. Right? We tested one path through our code, right?
Correct. Yeah.
Okay.
Yeah.
Making sure. We're going through a lot here really fast.
I was nodding. Yeah.
Okay. So here we expect on the next one, process day, to handle a date. So I've got the same user, except I've got a start date. And I specifically wrote these. And what I actually did when I did this, and let's show this. This is a good time to show breaking things, okay? Let's change our date from 10-1 to 10-5. Because this will change things, because we're passing an item in now, and it's going to do a calculation, right? And my original calculation showed that it should have been 273 days. Well, now it's not going to be because I changed from 10-1 to 10-5. So let's run. And this one is in API service. Okay, now this is going to break. And remember, we wanted to test a broken one too. Okay, see how we figured this out. We're going to get red, lots of red. I suspect. Let's close out the API service because we just want to get the test here. And that's weird. Handle the date. Why did that? Well, that should not have passed. Now I'm curious. Let's change it back to 10-1. Let's see. Let's change this to... Let's change it to 0-1. Now I'm curious because that absolutely should not have passed. That's really weird. We want to break it. We want to break it in a particular way. Oh, you got to be kidding me. I have a false passing test for some reason. Odd. Okay, well, let's break this another way. I'll figure that one out later. I'm not 100% sure.
Okay.
I'm sure somebody will pop up and say, "Hey, Bob, this is what you did." We're changing the number of days. Okay. I know it's 273. This is how I figured out it was 273. I threw a number in there. I didn't know what it was. And I wanted to see what it calculated to. Oh, you gotta be kidding me. What am I doing wrong? Source, spies. Oh, I know what I'm doing wrong. All right. Everybody online watching this, I apologize. Yes, we can all make this mistake. Watch this. I did not save my file.
Happens to me all the time, Bob.
Bang your head against the wall moment, right? Named the variable wrong, didn't save the file. Yeah. Let's watch my tests run and fail.
There we go.
Yay. Okay. It's fun when you can get excited about a test failure, right? 3 times it passed. When it shouldn't have. All right, so how do we...
When it shouldn't have, yeah.
We get this big ugly thing. Right? And it is. Look at this. This is big ugly. Red all over the place. All this stuff. Okay. API service. We know we're an API service. Okay. Here's the reality. You're never going to run one file of tests. You're going to run your entire test suite. It's easier just to run a whole suite.
Exactly. Yeah.
Okay. You're going to have... At the moment, I've got like 883 tests running in the test suite I'm working with. Okay. I need to know which suite. So the first part is going to be that API service. That tells me which file. Right? API service test. Okay. Expect process day to handle a date. Well, I come down in here and I'm looking, okay, it's a process day. So I'm at the top of my file. I just opened it up, but I'm going to go control find. Remember what I said about the double quotes? Process day. Oh, I should probably turn off the exact match. That would help. And I find 2. All right, well, I got 2 of them. All right, process day to handle a date. To handle no date. Well, it's not that one. To handle a date. There we go. Naming. Easy to find, right?
There we go.
Okay. And this one's wrong. And why is this one wrong? Well, it expected 273. And what you're going to see here is expected received. Okay, so 1 is the value you've got in here. So I've got 273 in here. But it received 277. So item.days is now 277 because I changed that date from a 1 to a 5. I changed the date by 4 days. Right? So I'm just looking, primarily what I do is I look at the expected receive first. Unless it's a massive array or something like that that you're dealing with. It should be pretty easy to see where the difference is.
Yeah.
Okay. Not every test suite colors them that cleanly. What I've had to do in a few cases where I've had longer objects or things like that is I'll copy them out into another file where I can then clean it up and break them down and look at them side by side and go, oh, there's the difference.
Got it.
You could even use a diff checker. There's online diff checkers that'll say, hey, give me this text and let me tell you what's different about them. If you have really, really long ones. I've had like 1 or 2 scenarios in 6 years where I've had to do that. Okay, so now I know, number 1, which file it is, number 1, which test it is, and what the problem is. Well, I know the problem, because we did it, is that was a 5 and it should have been a 1, right? So I saved that, I rerun my test just to make sure I didn't break anything further, which I can do. I'm very good at that. And we'll see that this is working.
And the results are.
And while that comes up, I'm going to reopen this to see that we're done with Spies here on the live code. Okay, so now we're going to jump back to our slide deck. And we're going to move forward again because the next thing are mocks. Okay, mocks are quite often tightly coupled to implementation details. Okay, and they can make code harder to refactor. Okay. As I said earlier, you can't create mocks in Jasmine, which is why I'm using Jest. Okay, it sets the expected behavior on a real object or function. That sounds familiar, right? Like our spies and stubs we were working with, right? We don't replace functionality; we change its behavior in specific cases.
But they all don't replace.
Correct.
Right.
Well, they depending on how you set up the mock. A lot of times the mock will stub every function with the assumption that you're going to go in and change the behavior for the ones you want.
Got it. Okay.
The advantage...
So put an asterisk on it.
Yeah, well, yeah. Part of the advantage of it is you don't get any surprises. If new modules are added in, if new functions are added in, it accounts for that.
Got it.
On the negative side, something gets removed and you're dependent on that chunk. All of a sudden, you're trying to change implementation on something that doesn't exist. Okay. Pluses and minuses in both cases. Right or wrong, to me, it's always been kind of a scenario by scenario case. And you're going to write bad tests. It's going to happen. Okay.
Yeah, of course. Yeah.
One of the things I always suggest is break something. Make sure it fails. That's why I was getting really nervous there when that wasn't working. Yeah, I forgot to save my file. Had I actually saved my file and those still passed, that's a big deal. That's a false positive, right? Yeah. That kind of function, it's not typically going to happen there. It's with your async functions where it's going to happen, your API calls and things like that. You know, I've seen cases in promise chains of folks that wrote false positives upwards of 3,000 tests. That's a lot of rewriting when your tests could be failing, but they're returning a positive result. Okay. So just test that they fail first. That's why test-driven development is so popular. Okay. So if we look at this, we got a function, a for each. I wrote my own for each function. Don't think this is the for each function tied to arrays. Okay, it takes an item and a callback. It loops through the items and fires callback against each data point. That's simple. Okay?
Right.
So as I look at this, what am I looking at? And I want to step into here. Callback. Callback is the piece that we can mock here very easily. Okay, so in our test that we write down there, we create our mock callback, which is a stub that's past the function. Remember I told you normally you put a function inside there?
Right.
And this becomes an arrow function. It's taking a variable x and it's adding 42. Right? 42 is always a good number that gets added in tests and things like that, right? The meaning of life and all that kind of stuff. Right, there we go. So I execute. Okay, here I'm executing for each. I'm passing an array of 0 and 1. I'm firing the mock callback. Now, I specifically did this scenario so that you can see some things that happen. Mock callback has an attribute on it called mock. Mock can tell you the number of calls that were made, so calls.length. You can reference the 0 call, the 1 call, and actually see the next one over. So what you see here is that 0 and that 1 are the actual calls, the reference to the actual call. The 0 over here is where is it in the variables that were passed in. So in this case we have data, which is only 1 and it's 0 indexed. So if it had data comma something else, the next one would be 1. Okay, so you can reference which variable was passed and check their values. And we can actually use results to check 0 and 1. In this case I only checked 0, so 0 plus 42. That's the 0 index of results. So that's the value, the number 0 was passed in on that 0 index. And added to 42, so 0 plus 42 is 42. So if I had checked results sub 1, it would be 43. In fact, we can change the test when we get to the live code and try that out. Okay?
All right, yeah.
So we've tested failure.
Do it.
We can kind of skip that. We're going to go look at some code again, because code is clearly infinitely more fun than looking at the slide deck, right? Let's clear this, because that's really ugly. Let's get rid of you for a second. And let's go look at what we have in mocks. Okay. We've got the API service and the random, and we're going to run through those quickly. There is a math app I want to take a look at. We'll spend some time in there. And then we've got these simple examples here too. Okay. So the mock 001. This is, again, I'm showing really simple mocks. Okay. We've seen this. Running a mock with Jest function. We're getting a result from mock Bob. Well, the result is going to be undefined because nothing was passed in, so it's returning undefined.
Exactly, yeah.
Okay. We expect it to have been called. We expect it to have been called one time. We expect it to have been called with Bob. Would I ever write all three of those in one test? Probably not. Okay. I want you to see they're there. Okay.
Okay, cool. Appreciate that.
So, testing a mock implementation. So this is a mock with an implementation. It's going to return Bob. Okay. So I call the mock, and I'm passing it called with. The result equals Bob. It returns Bob. Okay. But it was called with, call with. Wow. Boy, I set myself up for that one, didn't I? It was called with, called with. Okay. Test another mock implementation. Okay. Yeah. So up here we passed it a function. Up here we're using mock implementation to pass it. It's the same exact functionality in terms of what we're testing. Different way to mock it. Same end result. Okay. Okay, to test a single call with the mock implementation, so we set up our mock implementation. We fire our first call. Our result is Bob. We expect it to have been called with first call. We fire a second one. Okay, since we did this mock implementation, now look, there's a difference here. It's a mock implementation once.
Oh, only one time.
It only fires one time. Okay. On the second call, we get undefined, but we can still test that it was called with second call. The implementation was only one time. That gives us some advantages down the road. We'll see that towards the end of this, okay? Expects to test a mock with returned value. So we created a mock. We gave it a return value, and yes, I could have done a dot up here. I'm trying to show you different ways you can apply things, okay? We fire it with called with. We expect our return value to be Bob, and we expect it to be called with called with. Okay. So I actually didn't give it a function. I just said, hey, return this. I can actually put a function in there and look at what comes in and potentially give different responses if needed too. Okay. With return value, you can't do that. Okay. Test a mock with a promise resolution. Resolved value. So yes, I can have a function in there that actually returns a promise.resolve or promise.reject. Or I can use this mock resolved value. Okay. So we call our mock. We can see that it resolves. Now this is an interesting one that we don't have in Jasmine, which is the dot resolves. Okay. Without that, we'd have to do async await. So put an async on the function here for the test and await before the mock. Based on that, we can then test result to equal. In this case, to resolves is saying, hey, this resolves to Bob. Okay. And here I actually did it with the async await instead of the resolves, dot resolves.
Okay.
Okay, so you can see that both work. Okay. So this is just source /mocks /mock. So you know what I'm going to do? I'm going to do, well, no.
What are you going to do?
I was going to run just those, but I don't think I can run just the root. Test.js. I was going to run all four of them at once and just say, hey, well, now let's look at the code, but they're in the root, so if I ran that, it's going to run API service math and random as well. So let's just run them one at a time.
Right.
Okay. All 7 paths.
Okay.
Okay.
Hey.
Nothing complicated there. We're looking at 2. And it's a do add function, A and B. It fires the callback passing an A plus B. Okay. Again, we should be thinking, hey, that's a callback. I can mock the callback, right? So really simple here. We create a mock callback. We call do add passing a 1 and 2. We expect mock callback to have been called with 3. Does that make sense?
Yes, it does.
Okay. So let's test it. See that it's still working. As you know, my code can do strange things at times. Quite often does when you do.
Yes.
That's what happens when you have a live demo, right?
Especially recording.
Even a recorded demo, yeah. Well, you've seen before in my recordings, I very rarely take out the things that don't work. Now, if my daughter, who just got home, who's 2 years old, comes down here screaming, we may not leave that in. Okay, so we passed. All right, so let's look at the third one. And this one came from the Jest documentation. So I did document in some of these files where some of the stuff came from, or the examples.
Okay.
This is an example I really liked. And this is a for each again with the callback. Okay, this is the one we looked at before. Right? And what did we say? We wanted to check that second result because we didn't check it before. So let's put another expect in there. Assuming I can copy paste, right? There we go. I work on a PC all day, and now I'm switching to a Mac, so it just my mind gets boggled. So we know we want to look at the second result, right? That's the one.
Yeah.
It's 0-based indexing, and it should be 1 plus 42, so it should be 43. Okay. Now this test worked before I changed that, so let's see what happens. Should get through 3 pretty quick because we've already looked at the code and the tests. Right. So we're going to check that. Made 2 calls. We're going to check that the first one was called with 0, the second one was called with 1. We're going to check that the first result is 42 and the second result is 43.
Right.
And we got it. Ace that one. Okay. I am not going to push that line 20 up to the repo. Okay.
Okay.
Oh, that was not saved. Let's save it and check it, and then we'll undo it. Man, that save is getting me tonight. I do like having the mistakes in. I mean, we all make mistakes as developers. I like pointing that out.
Exactly, yeah.
Okay, I make lots of them, trust me.
Honestly, I think that's the best part about
So I'm going to come back. I'm going to take these out. There we go. And save it again. Let's just double check that it's running. And while that's running, I'm going to go to 4. I'm hoping it passes so we don't have to do anything weird. Okay. This is mocking return values. So we're setting the original value. So here we're setting up a test mock. And we're just executing it. Should be undefined. We've seen that one before, right? Mm-hmm. But what I really want you to see with this is what we can do with a Jest function using mock return value once and return value. Return value once is limited. One time.
Yeah.
By chaining them like this, what I'm saying is the first time I wanted to return 10. The second time, I wanted to return the string X. We're just using mock return value as the third one in the chain, so all of them after that should be true. And if you look at my tests, that's what I'm testing. So I'm running test mock. First time should be 10. Second time should be X. Third time should be true. Fourth time should be true. And if I put a fifth, sixth, seventh, it would be the same thing. Okay?
Okay.
So let's test that suite. So you can chain those, which is really cool for testing purposes when you have complex scenarios. Okay?
That's pretty dope.
Yeah, it is. Here we go, here we go, here we go. Yay, we passed. All right. Let's get into the really cool stuff. We need to go through random really fast and API services really fast, and this is in terms of mocks. So we're going straight to the test because you've seen functions and app. And there's my ad that I created. Okay. Here's the thing that's different. Okay, we brought in random, which is the app. We brought in the functions like we did before. I just mocked functions.
Yeah.
Okay, I created a mock. I wrapped it in a mock. I created the add function, okay, because it's using the FNS. I could have used random.add. We're mocking random. We expect add to get a number in a random. So we have a mock get number for the Jest function. Okay, we're creating a stub mock get number. So if we use the random add, that's the original imported one, not this one.
Okay.
We pass it to and mock get number. So if you remember on that add, you passed it a number and a function. Okay. The add could be a string or function, but we're assuming number.
All right.
Okay, so our 2 plus our 3 should be 5. Nothing complicated there. Okay. We created that mock that we're injecting. Okay.
Okay.
Now, using this add, we pass it add 2. Here's the trick. Functions, FNS, has been mocked. Okay?
Okay.
So it essentially becomes a function that returns undefined. So you're trying to add 2 plus undefined. So our result is going to be all wonky on this one, but we can test that function get number was called. Here's the trick. Had I not had this in, well, the problem we're going to get is functions get number was never mocked or spied on. Because it's not mocked or spied on, you can't run that expect. You can't see what happened to it. Because we have it mocked right there on line 5, we can check that it executed. It's mocked. Remember what mock does. It replaces each function with a stub.
Yeah.
It's not a spy.
Assuming, yeah, okay.
So the original functionality can't run. It's going to return an undefined. Unless we come in and say fns.getNumber and give it a mock implementation.
A certain way, and then, yeah.
Because remember, it's already stubbed, and we can change that stub. Okay.
Exactly.
So let's test this real quick. And that's going to be mock / random. Okay, so we're able to go a little further when you're using mocks with that random, right?
Yeah.
And I'm hoping you can see how you might have been able to use spies in there in different ways. You can see that there's a whole bunch of different ways you can set things up. We're still passing. Good. So let's look at the API service since we've seen that one before too. And on API service, that's just an image that I used. So we still have the same service and our test suite. Okay, so let's take a quick look at our test suite. As we're coming down, we let our service. We have our mock users. We've imported it. We set up our service. Before each test, I'm setting up a stub of the global fetch. Okay.
Okay.
And I'm setting that promise resolve that we did on the other one, on the spies side. Okay. We're not spying on it in this case. We're stubbing it. Okay. We do a mock clear. Okay. This is read as a mock. We're making sure that no other mocks from other tests have been run and are still doing anything out there. Okay.
Yeah.
And I set up my mock return value. Here I'm going to spy on the process dates. And look how much shorter that is than it was last time with the spies. because we've already stubbed it. We've
Yeah.
already changed its behavior. Okay.
Mm-hmm.
Here we can do it since fetch is stubbed. We can set up a mock rejected value. Remember that mock return value, the mock
Yes.
promise return value? Well, we have a mock rejected value. We're returning it one time, sending an error code, which pushes it through the catch branch. Okay. You can see how it subtly changes what you're doing with the tests. Not huge, just subtle changes. Okay, filter users. Filter users shouldn't have much change to it. Okay, because filter users is not interacting with, and actually all the functionality down below. None of that is interacting with that mock of the global fetch. It's only the one function that had the global fetch. Okay, but you can see the subtle changes that gives your tests. Okay.
Cool.
You could see them as advantages, disadvantages. I use the Spies so much that I prefer that methodology. So let's look at this math app, and we have an app
Right.
that do add, do subtract, do multiply, divide. This is a really complicated math app. Okay. And it executes math.add, subtract, multiply, divide, passing an A, B to each of those, and exports those functions. And if you look at the math add, guess what it does?
Ah,
Math
there we go.
functionality.
Okay.
Okay.
I was wondering with the math file what it
Yeah.
is.
Okay. So you import that into app, and then app does that stuff. So if we look at the app 001 set of tests, we bring in app, we bring in math. Okay. Here's the thing. This is an interesting one I want to look at, because what I did here was I stubbed out add and subtract. And this is a fairly common practice. Okay. It's less common for a couple of reasons. Okay. Because stubbing it this way, you have two, and we know you have two sets of functions that you're not stubbing.
Yeah.
Okay. What I want to show is, I think it's in, no, it's not in 2. Where did I put it? Oh, maybe was it still in there? Did I put it in the wrong place? There was a commented out line that is not there. All right. Because what you could do is a jest.mock of
Okay.
math. And it does the same thing that you're doing right there. Okay, and somewhere, I had the line in here and it was commented out and I don't know where it went. I apologize for that for those of you watching. You can do, you have to give it the file name. And if you remember what I said earlier when we had the FNS, it creates a stub against every function. This is a stub against 2 of the functions. That's a stub against every function. Does the same thing quicker and in my mind more efficiently across. Okay, I'm going to leave the original in, and if somebody wants to pull that code down and play with it, they can do that too. Okay. Maybe that's why. Maybe I was getting a weird. Yeah. I'm just going to take it out. Okay. And make sure I save my file. There we go. So math add, we're doing the do add. We can check that math add was called with 1 and 2. It replaced functionality because we mocked. Okay. So down here, here we go. This is what I did. I did a 2 set test suites. That's why my code wasn't up there. 2 different test suites. Wish I'd read this ahead of time to make sure I remembered that, but it's been 2 weeks. I apologize.
We'll do it live.
So the first one is using jest function. This is a jest mock, where we're mocking the entire math suite. The tests are exactly the same. The difference is that the subtract and divide are also stubbed in this case. There's no accidentally missing one. Okay. We can add functionality back in, but it would be mocked functionality. Okay, that's the danger with mocks. Okay. All right, so that's the math app. We've seen everything in mocks here, so let's go back to our slide deck, and we're getting close. I said I thought it might be about 2 hours, so we're getting pretty close here. Let's see how far out we are. We only have about 7 or 8 slides left, right?
But yeah, we have like less than that, I think.
So, dummies. We talked about dummies. Dummies are values that don't serve any purpose other than they're a placeholder. Syntax requires it. Okay, in this code, in this demo code, this is straight JavaScript. React can be run with TypeScript, and if it were my code, I'd prefer it. Okay, Angular is run with TypeScript. It's by default. Okay, you have to work to get TypeScript out of Angular. If you have typed code and you're telling it, hey, the second value is a string on this function, guess what you have to pass, even for the tests? Okay? If it's a case where it's passed through and you're stubbing out code where it's passed into, or spying on it, you have to have something still to pass in to make it behave correctly. Okay? So you need those dummies to pass through. It's data of some sort that's just a placeholder. Nothing more complicated than that. Okay?
Got it.
So code coverage. In code coverage, you're typically looking at statements, branches, functions, lines, and I hear people all the time talk about, is it important, is it not important, does it have value? Once you set a percentage, people are going to meet that percentage, they're going to do what they have to do to get past that percentage. I agree and disagree with that at times. Angular in particular, its coverage suite, and you'll see it here, the cover suite here with Jest is pretty good too. It wasn't always this good. It's improved. I like proof that my tests have looked at every line of code, every branch through a function. Every function has been tested, and this is what this tells us.
Okay, got it.
As much as I possibly can. I like that proof. I like that certainty when somebody tells me my code's broken, that I can doubt them because of the tests I've written. Okay? So let's take a quick look at code coverage, and we have to be a little careful with it because right now we're going to have some weird results because we run partials. So we're going to run Jest coverage, and this might take a bit longer than 5 seconds.
Okay.
But what's happening here? We have to run the entire test suite with coverage because what it does is it generates the coverage files. And we're going to look at the coverage files here, what it's done. Really not bad. I mean, just a couple seconds longer than we expected. It's still dinging along here, but you can see we've got things starting to pass. Really kind of cool to watch it that slow, actually. I'll be honest. It usually goes by so fast I don't get to see that. Okay. That was kind of cool. Okay. Lots of tests.
That actually is, yeah.
15 suites, 52 tests. And what it regenerates is this coverage folder. Okay. And the coverage folder has a whole lot of stuff in it. It created a bunch of HTML files and things like that. And there should be this lcov.info file. That's a critical file. I never look at it. It's a critical file, and I never look at it because what it's for is automated systems can open that file and figure out what happened on your tests.
Okay.
So when you want your CI/CD to look for passing tests, that lcov can give them percentages. Hey, are you at 70%? Are you at 80%? Are you at 90%? That lcov file can give them that information. Okay. What's important to us is this index HTML file directly underneath coverage. Don't look at any other HTML files. That's the one you want. They're all based off of this one. I'm going to open it in live server. This is a trick I've learned. Although it's going to open up Chrome somewhere off the screen that you will be able to see here for a second. There we go. I'm going to drag it back out here. Okay, because this is what you get.
Oh, there we go.
Okay, this is a coverage file. Okay, we're at 90%. We're 100% on branches, 100% on lines. But our functions and our statements are off a little bit. We're doing really good on the API service and on the random, the mock API service, the random and the API service. But you can see on the math and the random here, we're missing a few things. I mean, it's pretty clear that we're missing a few things, right? So let's say we go into this math app and we can figure out why. Because you have the app.js file that's missing a few, but it's pretty good. And we got the math.js that's missing a lot, right? But as we come in here, it gets really easy to see what we missed. We never tested subtract, multiply, or divide. Nothing in our test touched those. Okay, so if we really want coverage, we need to test those. And if we look at the app.js, we tested do, add, do, subtract, but we didn't test multiply and divide.
Okay.
Right? But notice, we did test do subtract, right?
We did, yeah.
But we tested it with a mock. So the original function never ran,
Okay.
right? Because the original function never ran, the original function never got tested. One of the dangers of allowing one function to run another one to get test coverage.
Wow.
Okay. It becomes pretty easy what you're missing. And I get people all the time saying, hey, I want to cover the important stuff. I'll be honest, more often than not, the important stuff is usually not where the problems are. It's usually the other parts that cause the bigger problems. I'd rather have as much coverage as I can rather than not enough. Okay? There's a lot of value in that. And these reports are pretty easy to read, as you can see. There's nothing super complicated here.
Right, yeah, that's true.
Okay. So what I usually do is I write my functional code, I write my tests. I check a 1 or 2 for failure and then correct. Then I come back and look at the coverage reports and get the coverage to where I need it to be. And I tell folks I'd rather have as high as possible, because if you're dependent on a system that says, hey, you've got to have 80% coverage, it's amazing how few missed functions can get you below that number. And then you got to write all these really odd tests to get them to pass really fast so that you can get enough to get through. You know what? If you're way at the top and you're in a critical emergency scenario, you got to get something in the next 5 minutes, and you're going to push it through a CI/CD to get to production, and the entire team's waiting on you. I'd rather have the room to skip a few tests right there to get it through by having as many tests as I can. Okay? So that's coverage.
All right.
Okay. Oh, we did the demo. Summary. We talked about stubs, we talked about spies, we talked about mocks, and the biggest thing is don't get hooked up in the definitions. Pay attention to. Go back through these a couple of times and see what those different areas actually do. Okay, and how that could be applied to functions you're writing. Okay, look at how can you simplify your functions to make some of these tests easier. Is it possible? Okay. We talked about dummies. Pretty straightforward stuff. We talked about code coverage. In there, you saw asynchronous activity in a couple places, but in particular with the API service. We talked about dates and how we pass dates in rather than allowing the new date inside the function that I then have to account for. Okay, because it causes all kinds of weird issues, side effects. Okay. Any major questions?
So you pretty much answered the question right there, where it's like, don't pay too much of the definition of each of them. Just like go back and look through them, because essentially, and you correct me if I'm wrong, what I got from this, like, they pretty much do the same thing, just with an asterisk on it, pretty much.
Mm-hmm. Yeah, they do different. They do the same thing essentially in different ways. So what is it you're trying to do? Are you trying to change the behavior of that function to be more stable for your tests?
Yeah.
Or are you just trying to watch it and allow it to pass through and use that functionality? In some cases you need to control the behavior.
Right.
In other cases, you're okay with it passing through because it's doing something really simple. Changing all the usernames to uppercase. Okay, I might allow a pass through on that one. I'm usually of the mindset I like to explicitly test every function. Okay. Now this is intermediate test. We are going to talk about React, and one of the ones I want to point out there is React is a little different, and we will talk about that when we do the React record.
Awesome.
React has the capacity to test the DOM elements as well. It uses JS DOM, which is very, very similar. Because of that, there's a mindset for many React developers that, hey, I don't want to test the functions. I want to test what occurs in the DOM with my components. I haven't decided if that's right or wrong. I mean, it's good to do. It's good to test, but I think that potentially something is missed in not testing your functions as well, which can be done. Okay.
Okay.
I'm not going to debate right or wrong. I'm going to showcase what can be done on both sides of that argument.
That's fair.
In
Yeah.
that one. Okay. In Angular, it's pretty simple. You can test the DOM elements, but it's kind of a pain in the butt to do, so it's easier to test because everything's class based in Angular, and it's much easier to test those modules and functions.
Right.
Pretty straightforward to do, actually. Okay. So for those watching, thank you for hanging out for the entire 2 hours of this record. Lewis, thank you for hanging out with me the whole time. I hope we got your questions answered.
No, for sure. And thank you for the experience because I've never
Sure.
actually like seen this before.
Well, I'll be honest. If it hadn't been for you and Shamir, these wouldn't exist. Okay.
We appreciate that.
Seriously, I recorded 1 or 2 things for the job stuff, and you were the 2 that said, "Hey, here's some other ideas," and this
Yeah.
is really pushed. And I mean, we've still got another dozen or so in flight.
And
So
I'm looking forward to it.
thank you for that push. This has been a lot of fun. I'm still amazed we got through the entire 2 hours without like a screaming child running through my room. So that was pretty cool. All right. Thanks for coming. Hope you enjoyed it. Hope it was helpful.
Thank you, everybody.
See you on the next one.